Hey, warm greetings to all. Welcome back to another video on our Java series. Today, in this video, we'll be talking about constructors, this keyword, and super keyword, which you might have encountered within Java. So for the purpose, I am using the same example that we have seen within inheritance, the same child class extending the properties and behaviors from his parent class. Alright. So what I'm going to do is I'm going to introduce a new parameter within the child class called salary, and I will try to access the value of salary within my main method. I have already created the object of child here in line number 25, and I am using that to access the salary parameter. So as you can see that I am not initializing the value of salary here, am I? I am not giving any values like salary equal to 20,000 or something like that. I am not doing anything as such. I am just declaring it. I am not initializing it. Am I initializing the value of salary within the main method? No, right? If I had to do that, I would have done something like c1 dot salary equal to 20,000. But am I doing something like that? No. But still, I am attempting to print the value of salary. So what would happen here? Run as Java application. You can observe that in the console 0 has been returned. But have I given the value of salary as 0? No. I haven't initialized it. Then who do you think would have done this job? Who do you think would have provided the value as 0 for my salary parameter of child class? Not me. Then who? So that is where constructors comes into picture. So constructors are basically normal Java methods which you can make use of so as to initialize the parameters of a class. And these constructors gets invoked at the time of object creation, which means that when I am creating this object in line number 25 using new keyword, new child function, what actually happens is it leads to the invocation of its corresponding constructor. Alright, and within that constructor you can initialize the values and parameters of your whichever class you are working with. But again, another question comes, where exactly is this constructor? I have told you that, okay, when I create the object, the constructor will be invoked. And this constructor is responsible for initializing the class parameters. But where exactly is this constructor? I haven't created that explicitly, have I? No. But still, a constructor was created who was responsible for the class variable initialization. And who created that constructor for us? Obviously, the compiler. So if you haven't created a constructor explicitly by yourself, then your compiler would create that for you. A default constructor will be created for you by your compiler. And then depending upon the data type of the variable, a default value will be supplied to it. Alright, so which means that if I am giving, let's say, double, what would be the default value? The default value would be 0.0. If I execute it, you can see that the salary will be initialized with 0.0. What if you are giving string? It will be initialized with null, right? Java application, you can see. So depending upon the data type of your variable, they will be initialized with the default value. And this is done with the help of constructors, which is created by a compiler. So if you want to have a control over initialization of these variables, then you can explicitly create this constructor by yourself. And how to do that? I will show you. So basically constructors are what? They are just Java methods. They are just public Java methods with no return type and the name same as that of the corresponding class, which means that public followed by no return type, and the name of this would be same as that of the class in which that constructor is created, class for which that constructor is created, and in our case it is child. Just like that you can create a constructor. So basically what compiler does is something like this, right? what compiler did was that salary equal to 0. This was something that your compiler was doing, somewhat like this. All right. So when we execute this code, what happened? Run as Java application, 0 was being printed. But instead of the 0, if you want to print some other values, let's say 20,000, run as Java application, you can see what happened, right? So the program flow is pretty simple. In line number 30, when I have created the object of this child class, what happens? New child function leads to the invocation of the corresponding constructor, that is public child function. And within this child function or child class constructor, what am I doing? I am initializing the value of salary parameter, and that has been initialized with 20,000, and the control returns back to line number 32 where I am printing the value of salary, which now is 20,000. That is why 20,000 was returned in the console. So this is how you will be using constructors for initializing the value of class variables. I hope that much is fine. Moving forward, let's say that instead of this, I wanted to pass some values to the constructors. Will I be able to do that? If you observe here at line number 30, new child function, you can, and if you are familiar with the function calling or the method calling, you might understand that it is very much similar to that only. Right, here it is similar to new child function. It's like I am making a method call, and this is equivalent to a, or this is somewhat like a Java method. So if I want to pass some values to the constructors at the time of object creation, I can do that here itself. Here I can give something like 20,000. So if I am passing some values at the time of this constructor invocation, then that constructor should be capable of accepting such values. And that can be specified here. It will be accepting a integer value. Alright, and now salary equal to A. Now my program is much more dynamic. Now at the time of object creation, I can pass some values. When you're actually working with a code, you might have to interact with a lot of variables. You have to create a lot of variables, right? So creating a different name for your local variable that needs to be matched with corresponding instance variables might lead to a lot of confusions. If in case you don't know what an instance variable is and a local variable is, it's simple. Instance variable are the variables that has been defined for your class, which in our case is salary for child class and this age and name for parent class. These are instance variables, all right? Whereas local variables are the variables that has been defined within the scope of a method, or which in our case is a constructor that I have created. So you know that some methods will be accepting some parameters, right? And those arguments will be having its scope only within that methods. Outside of that method, those value or those variables cannot be accessed, right? Those has been defined locally to such methods. Here this A has been defined locally to this constructor. So that is why this is termed as a local variable. Okay, so that is the difference between instance variables and local variables. I hope that is clear. Anyway, my point was, what if instead of giving a separate name here, I give the name as salary itself? Because in an actual code, you might have a different or a lot of variables associated. You might have a lot of instance variables. So creating different variable names for all your local variables will be hectic, because you will have to match those values with the existing instance variables, right? So it might create a lot of confusions. So for that, I am going to keep it as salary. So now, so if even if I am having multiple values, I know that okay, this is the local variable that has to be matched with the salary instance variable. So now I am limiting different names that has been taken for local variables, right? But now a new problem arises. Now if I do this, what is happening? Salary equal to salary. So which one is the instance variable and which one is the local variable? Nobody knows. I mean, we know that this is the instance variable and this is the local variable, but our compiler doesn't know that, right? So that can be specified with the help of this keyword. I am specifying it to the constructor that this is the instance variable and the other one is the local variable. Okay, so this keyword acts as a reference to the current object. All right, this keyword acts as a reference to the current object. So if you observe the code, which is the current object associated with this program flow? C1, right? So here I am creating an object C1, and during that time only this constructor was invoked, right? So the current object is C1, and I have told you that this acts like a or this keyword corresponds to the reference of your current object. So here in our case, this keyword is the reference to our current object, which is C1. So this is equivalent to C1 dot salary equal to local variable. So whatever value we have passed here, that will come here, and that is given here. So this is equivalent to C1 dot salary equal to 20,000. Why? Because this keyword corresponds to the reference to a current object, and in our case the current object is C1. That is why it functions like this. So basically this keyword can be used to indicate if a variable is a instance variable, or in simple terms, if you see that okay, this dot salary or this dot some variable name, then you can identify that that variable is a instance variable, and obviously the other thing would be the local variable. Technical definition would be this is the reference towards our current class object, which in our case is C1. So C1 dot salary equal to 20,000 will happen here. As a result, if I execute this, what would happen? The value of salary will be printed as 20,000. So this is how you will be initializing the variables within a class by making use of constructors. Alright. So here let me ask you something. I am going to create another object of my child class. Child C2 is equal to new child function. Alright. So now what happens? I am not passing any values, which means that there should be a constructor that should be giving default values to my instance variables, right? But here if you observe, the constructor child function is undefined. Why is that? Previously compiler created it for me, but now compiler is not doing that. So here is what your compiler sees. If you have defined at least one constructor explicitly by yourself, then the compiler won't do that for you. The compiler won't create any constructors for you. So if in this case I want to execute this code, then what should I do? I should create a default constructor or a parameterless constructor to default the values of my C2 object. Yeah. So now it would work. Okay, I hope that concept is clear, right? Okay, let's leave this out of the equation for now. Let's come back here. Here, if I try to print C1 dot age, what would be the output? This age is the parameter for your parent class. Is there a constructor defined for your parent class? No. Am I invoking any object? Am I creating an object for your parent class? No. So even if the compiler is creating a default constructor for you, can it be invoked without creating an object? That is the question. The only thing that we know is that this parent class got inherited by child class. And for child class, I do have an object created. But we don't have any object created for parent class. So how would this work? Will this throw any error or a default value will be printed? Yeah, you can see that a default value is printed. So a constructor invocation does happen here, but we are not sure from there, right? Do you have any guesses? So this is the another thing that you should be familiar with. always the first line of your child class constructor will be a call towards your parent class constructor. Okay, always the first line of your child class constructor will be a call towards your parent class constructor. Even if you are not doing that, even if you are not making that call towards your parent class constructor, who would do that for you? Obviously your compiler. Even if you are not explicitly making a call towards your parent class constructor, the first line of your child class constructor will definitely be a call towards your parent class constructor. So who creates a parent class constructor here? Definitely your compiler, because you haven't created any constructors explicitly by yourself for your parent class. So what would happen? Your compiler would create one for you. I am removing those methods to make it simple. Yeah, parent function. Your compiler would create something like this for you. Okay, so this is how it works. And how do you think the compiler would make a call towards this parent class constructor? By making use of super function. And what would this super function do? It would invoke the default constructor of your parent class. Alright, so here from this line number 17, what actually happens is that a call happens towards this parent class constructor, and as a result all the parent class variables will be initialized with their default values, and then the program continues from the next line of this child class constructor where the salary is initialized with the value that I have passed, right? And then it will come back to line number 30, and whatever I have done, the age value is printed. If I want to c1 dot salary plus c1 dot age, now if I execute it, you can observe the output. All right, so what if I want to plug in some dynamic values to this parent class variables? That can be simply done by passing values within the super function, because the super function is the function that has been used by your compiler to make a call towards the default class constructor of parent class, right? So if you want to explicitly call your parent class constructor by giving some random values or dynamic values, then you can explicitly make a call towards your parent class constructor using the super function and pass any values that you would like to plug in for the parent class variables. So here let's say that 42 comma Tony. Okay, so as of now, is there a parameterized constructor defined for your parent class? No. If you are not defining any constructors for your parent class, then your compiler would create a default constructor for you. Okay, fine. But if I have to pass some values to a constructor, then definitely this class should have a constructor that is capable of accepting those values. So that has to be created by me. Compiler won't create parameterized constructors for me, right? So I have to create that for myself. Okay, so we can create that now. Parent, so it should be accepting an integer value for age and a string value for name. Now I will be using this keyword, this dot age, which means the instance variable age is equal to the value of local variable age. The instance variable name is equal to the value of local variable name. So let us look into the program flow again. In line number 29, I am creating the object C1. So at the time of object creation, what happens? This corresponds to a call towards a corresponding classes constructor, and in our case that constructor should be capable of accepting an integer value, right? So here within this child class, when we come here, you can see a constructor that is capable of accepting an integer value, so that gets locked. The compiler will choose that constructor, and I'm coming to this line number 18 now. Why? Because always the first line of your child class constructor will be a call towards your parent class constructor. And the super function would invoke the parent class constructor, right? So the super function is searching for a parent class constructor that is capable of accepting a single integer value and a string value. So I am coming to my parent class. Is there a constructor that is accepting an integer value and a string value? Yes. So it matches to this constructor. Here the value 42 gets to this local variable age, and the Tony, name Tony, comes to this local variable name. And those has been used to initialize the instance variable age and name of parent class. After being initialized, the control comes back to line number 19, where the value salary or the variable instance variable salary will be initialized with the value accepted by this local variable salary, which is 20,000. So that gets initialized as well. And finally, what happens? The control comes back to 31, where the all values are being printed. Now on execution, you can observe the output in console. You can see that the entire variables has been initialized. So let's say that I want to pass these values for age and name at the time of creation of object. But I don't have to create any parent class object, so I will have to do with the child class object. Can I do that? Definitely, right? I just have to pass the values at the time of creation of child class object. Let's say that here I am giving 42 and name I want to give as Tony, which means that I should have a child class constructor that should be accepting two integer values and a string value. As of now, do I have a constructor like that? No. So I am going to create another constructor for doing that. Int salary, comma, int age, comma, string name. And within the super function, now I can pass in those dynamic values, age, comma, name. Now let's come back to the program flow again. Here in line number 34, we are creating the object of child class. So at the time of child class creation, what happens? It makes a call towards or the constructor gets invoked. In our case, we are having two constructor within our child class, right? So this constructor call corresponds to a constructor which is accepting two integer values and a string value. Among this, you know which one is capable of accepting two integer and a string value. The one from line number 22. So this gets executed. So what would be the first line of a child class constructor? A call towards your parent class constructor. And within this call, I am passing in two values for age and name. So this values of age and name has been passed at the time of object creation of my child class, which is 42 and Tony. So those values will be passed to the parent class constructor during its invocation. So I should have a parent class constructor that is accepting an integer value and a string value, which I do have from line number 7. Right. So when this constructor gets invoked, the instance variables age and name of parent class gets initialized with the passed values. After that, the control gets shifted back to line number 24, where the instance variable salary is initialized with the value passed to the local variable salary, which is 20,000. And finally, the control gets back to line number 36, where the entire values are being printed. Now on execution, what happens? You can observe the output. Now, without even creating the object of parent class, I am able to plug in values to the parent class variables by using the object of child class. This concludes the concept of constructors, this keyword and super keyword in Java. Before closing this video, I have one more thing to point out. The super keyword is not just used for invoking the parent class constructor. It can also be used for differentiating between parent class variables and methods. I mean, where would we be using this keyword? For specifying a variable as an instance variable, we will be using this keyword, right? Similarly, if you have to, if in any case you have to specify that, okay, this is the variable or method of parent class, then you can use super keyword. I will show you an example. Okay, let's consider that within my child class I am having a parameter age. All right, and I am going to create a method like void check function, just a simple method, and within this method I have to access the age parameter of parent class, and I have to give it as 42. But as of now my compiler doesn't know that this is the age of parent class. It can be the age of child class as well, because both of these classes are having the same parameter. So I should differentiate between them by using this super keyword. Now my compiler gets that, okay, this age parameter is the parameter of superclass. Alright, even there might be instances when your child class and parent class is going to have the same method. At those instances also you can make the, or you can specify the difference by making use of super keyword. Alright. Okay, so so the uses of super keyword is either to invoke your parent class constructor within your child class constructor, which definitely will be the first line of your child class constructor, that is important. And another usage is to specify if a variable or method belongs to the super class. So that's it. That's all I got for this video. I hope the concepts of constructors, this keyword and super keyword is clear to everyone. With that, I guess in the next video, we will continue with the next two pillars of OOPS, that would be encapsulation and polymorphism. So until then, it's your friend Sajin, and you guys have a great day. Bye.